So today I want to introduce what we call error handling and debugging in programming, right? So I introduced error handling in the file handling part. I'm sure you all get the concept of how you handle file not found exception. Like I said, you need to enclose your code with a try catch statement. You said we use what is called a try catch statement. This is one way of doing what we call error handling. Okay, so we use the try catch statement. So its syntax, we said it's try, like this. Then you put your body here, the body which we mean statement 1, statement 2, up to statement n. This. Then you catch. So for you to catch, you say except, like this. Then you put type of error here. Error here. Then you put the body of what you want to be executed if you catch that error. So here you put statement 1, statement 1 to n again. Okay. So this is the syntax of a try catch statement. So this is the body. So this is the body that will run looking for any errors. If we find this error while it's executing this body, then it will automatically exit this try body here. Then it will execute the exception body here. So the example for a try of the error that we did last time was a file not found. File not found error. I'm sure you are all aware of this, which you said for you to open a file in read mode, it needs to exist. If it doesn't, you need to handle file not found. If for any case that you might not find that file, the program will not stop running because of that error. Okay. So for today, let me just share the notes. I'm not sure if I did share these notes. Okay. Okay, let me share these notes. Okay. Can you confirm if you have received the notes, and also can you open them so that we'll move along? We'll move together. Kindly download the notes that I've sent and open them so that we can move together. Have you opened the document? Hello, have you opened the document with me so that we can move together?
Yes, we've opened.
Okay. So the type of error that you want to introduce first is syntax error. So if you remember from the first day, we talked about this word. We said syntax, it just means rules that governs you in any certain programming language. And you said each and every programming language has its own syntax, right? Which means the syntax from Python may be different from the syntax from Java, may be different from the syntax from C, from C++, and any other programming languages. So we mentioned what a syntax is, right? So if you compile or if you write any code and you don't follow the syntax of that programming language, you encounter what is called a syntax error. So these ones, you can see them without even running the code, right? So for example, this person was defining the function Great. Then we know the syntax for function here. We said you say def, then you put your function name here. Then you put round brackets. Then you said you put full colons. Then you put your body here. This is what we call syntax, right? Which means my function name will be replaced. Maybe I want to define a function called add. I'll put my round brackets. Then I put arguments if I have any arguments that I want to be added here. Then I put my body here. My body, which maybe I have A and B as my arguments. Then here I'll return A plus B like this. So this is just a syntax. Okay. So what happens if I remove this? I'll get a syntax error here. So if I try to run this code, you see at the bottom here, I'm being told that I do have a syntax error. Why? Because according to the Python syntax, this is a function definition. And after I've defined my function, before I move on to the body, I was expected to put this. Okay. So this is the first type of error that we want to mention. So this is the syntax error. So any syntax error, it means you are missing something else like colon, a comma, or you are putting it the wrong way, not the way it was supposed to be put. Like maybe it's a variable. We know the variable naming rules. If you don't follow those naming rules, you encounter a syntax error. Okay, so this is the type of error that we want to talk about. For example, here a missing colon at the end of the function definition, you encounter a syntax error. Then we do have what we call runtime errors. Runtime errors, these are the errors that you encounter during your program execution. So these happen during program execution and causing it to crash. For example, division by zero. There are a number of runtime errors that you can encounter, but the example that I gave here is the zero division error. So what happens here? If I have my num1 as 10, my num2 as 5. If I print num1 divided by num2, so for this one I'll get 2. So which means my code is fine, right? My program is fine. So if I put any value here, I'll get my result correct, which means my program is correct. But what happens if I put num2 as 0 here? So it will say 100 divided by 0, and that will fall into a runtime error. For this case, this is the zero division error. So my program is executed and ended. As you can see, which says that this means that my program has ended. This means that my program has started. So this has caused the program to crash. So even after this, if I was supposed maybe to print also num1 plus num2, my program will not even get to execute this. Why? Because it has failed here and it has stopped the program. So if I run this, you see that I only have my error here, and there's no total was supposed to be printed by this. So that's where error handling will come in now. So instead of letting my program to crash whenever it gets an error, I will do an error handling. So before this, I'll put, so this is the logic here. So I need to put my logic inside the try catch statement. So I put a try, then I put this, then this is the body, okay? Then I'll say except as usual, except. Then the type of error that you write here, like I said on the syntax, it has to exist in that programming language. You do not put exceptions that you want. So you put exceptions that exist. I'll give you a list of exceptions. I forgot to compile those. But that exception, it has to exist in that programming language, okay? For this one, what we want to catch here is zero division. Zero division error. As you can see, when you type an exception that exists, it will change the color. Like if I type errors like this, you see that this is not defined. So it is black, but This one is more like red or something. I'm not sure which color it is. So instead of for this program to stop when it gets an error while it's trying to divide num1 by num2, I want it to print division failed. Okay, division failed, dividend was 0 because num2 was 0. Okay, so what I'm saying here is, please can you try to divide these two numbers and print the result? But if you get an error while you're trying to do this, instead of stopping my program, can you just execute this? And when you are done, continue executing my program. So this time I'll get this statement and I also get my result, which I didn't get earlier. As you can see, there's no total here. But this time I should get my total. Okay, so if I run this, you'll see that I'll get my, which means the program has encountered an exception here. So when it encounters an exception, it will execute the body that you have told the program to execute. When it encounters an exception, it means the program will execute this, and when it is done, it will continue executing the rest of my program. So other than stopping here, when it gets an exception, it will continue executing my code. So this will only get executed if and only if the program encounters an error inside here, and it will catch the type of error that I've told the program to handle here. But if I put a number that is not 0 here, so it will not catch an exception while it's trying this because it's doable. I can divide 100 by 2, so I'll not get an error here. So this part will not get executed. We say this only get executed if and only if I encounter an exception during the code execution of my try statement. So if I run this time, I'll get the result for this and the result for this. This will not get executed. Why? Because the program will not get an error here. So if I run this, as you can see, I've got the result for dividing and the result for adding. So this is what we call runtime errors. This is how you handle runtime errors. Then the same with the example that we had when we did file handling, we said try like this. Let's just repeat it. Then again, save file is equal to open example example.txt. If you remember this example, we did it in read mode. Okay, then we say except. Okay, we put the file not found error, then we print. So instead of getting an error here, we'll print file doesn't exist. Okay, so if I run this, I'll get file doesn't exist. Why? Because it has tried to open this file in read mode, but this file doesn't exist. As you remember, I said if you don't put a absolute path, this file needs to be in the same directory as my Python file. But I'm in assignment, I'm not sure which assignment is this. In assignment 4, then I'm in this Python file. So in this directory, the assign 4, this file was supposed to be there, but it's not there. So what will happen here? It will try to open this in read mode, but this doesn't exist. We'll get an error. But if I create this file, desktop assignments, let me just create this file in here. Okay, this is the file name. So I do have now example.txt. So this time I should not get an error. Why? Because this should execute without an errors. So as you can see now, I do not get an error. Why? Because my error body didn't get executed. So this one will get executed if and only if I get an error while it's trying to execute my code here. Then moving on to, so these are runtime errors. I'll give you a list of runtime errors. But the examples are those: the file not found, the zero division, and so forth. Then we do have what we call logic errors. Okay. Then logic errors, your program will run fine and it will not crash, which means there's no any error that I can see by my eyes, but your program will produce incorrect results. Your program will produce incorrect results. We call that logic error. For example, there's a learner who did the factorial assignment, if I'm not mistaken. The code was fine. It worked for if you command it to calculate for a factorial of a number that is greater than 1. But if you give it 0 and 1, it was producing false results. So we call that logic error here. So for example, maybe the person was asked, for this example, the person was asked to calculate the area of a rectangle. Then he was given length and width, like this, length and width. Okay. So this one, this logic error, we do not handle this using the try catch statement, because it's not an error that causes my program to crash. Any error that causes your program to crash are runtime errors and syntax errors. Those are the ones that you need to handle. For this logic error, you need to know the results before you even run the code. For example, if I give my program 5 and 4 and I'm expecting it to calculate the area, so I'm expecting it to multiply length by width, but this person says area is supposed to be area, length plus width. So the result here will be wrong. So the program will run fine, but it will produce wrong results. So these ones are the ones that are most difficult to identify, logic errors. Why? Because you'll be given results, but it's up to you to know if those results are correct or not. Rather than runtime errors, before you even go to the results section, your program will crash somewhere along execution. Then it'll tell you that the program failed at this line, or it didn't find this file, or you tried to divide by 0. Then you handle that error. But a logic error, your program will execute very fine from start to end, but the results will be logically false. So, for example, here I'm expecting it to calculate the area of a rectangle. I've given it length and width, so it was supposed to return me 5 by 4, which is 20 square meters, but it has given me 9. So this is a logical error. So these are type of errors that you need to identify when you're writing code as a programmer. Okay. Then let's now deep dive into the try catch statement. Okay. I need to more detailed about it. So exception handling, right? It shows you how to manage runtime errors gracefully and continue program execution. So if you don't put an exception handling, if your program doesn't encounter an error, it will run fine. But the moment your program encounters an error, it will stop executing. So you need to put error handling for you to avoid that stopping of the program. So we put a runtime, we put try catch statements to manage runtime errors and to continue program execution. So I have did the try catch statement, its introduction, its syntax. So we said it's try, then board, then except. It's try like this. Then the board that you want to execute here. Then you say except. Then you put type of error here. Type of error here. Then you put here. This is now error body. Okay, like this. This is the basic syntax about a try catch statement. Then there is what we call finally, we haven't got it. So inside the program, right, I can catch a number of errors, a number of types of errors. For example, this program is catching the zero division error and the value error. So a value error, we get it when we try to convert data type, one data type to another. We did data types, right? We talked about integers, boolean, strings, characters, and so forth. So If you try to convert one data type to another and that data type is incompatible being converted, you get an error. For example, if I try to convert, maybe this is string AB. If I try to convert this to integer, I'll get a value error. You can see, like, if I try to say print, we said to convert, you use the int, right? If you remember, then I want to convert AB like this. So this will give me a value error, as you can see here. Why? Because it has tried to convert an alphabetical letters A and B to integers. But integers, they don't allow you to do that. But if I put 1 here, or 1 like this, so I will not get an error. I'll get my 1 as an integer. So those are what we call value errors. So if you remember, we were doing our assignments saying that you write a program that allows the user to put this, allows the user to enter this, but you need to put that in a try-catch statement and the end of value errors. Because why? If I say write a program that allows a user to enter two numbers and it should return the result. So I can say number 1 is equals to int, right? Like this, we say input. We said this int, we use it to take whatever the user has entered and convert it to a number, right? So I can say enter number 1 like this, which will run fine. Like this, okay. Then I can also ask the user to enter the num2, which is my variable num2 here, and we say enter num2. Then I can print num1 plus num2. So if you ask to write a program that asks a user or that prompts a user to enter two integer values and it should print the result, this is the program. But what happens, let me just run it first and run it with valid values. Like if I put 1 and 5, I should get 6, right? But what happens if a user enters something which cannot be converted to integer? Like I can enter 1 here, then I'll enter B here. So I'll get a value error. So this program works fine, but if you don't do error handling, your program will crash. So to avoid this, that's what when we use try-catch statements. So instead of this program to crash, maybe this program was supposed to add numbers, calculate them, do division, and so forth. So when it gets here, it didn't even get here. Why? Because it tried to convert the B that I've entered here to an integer, which I've entered here, which is the B, but the B cannot be converted to an integer. So we need that try-catch statement to handle error so that my program will not stop running. It will continue. It will just, we need encounters and errors. It will execute my error board, what I've commanded it to execute whenever it encounters an error. Then my program will continue executing the rest of the codes. So, like I said, you can put more than one type of error in your try-catch statement. For example, this one, it handled value error. I've mentioned about how the value error works. Usually, you encounter it if you try to convert one data type to another, which is incompatible. So, this one is a program that divides two numbers. Okay, let me just zoom out a little bit. So, this is a program that this is a body, this is a body, and this is also a body. This is the body. No. So this is a program that divides two numbers. So it allows you to enter a number here. Then you to divide 10 by that number. So if I give it 10, it will convert my 10 to an integer. If you remember, we said the input function, whatever you put here will be string. So if you need to perform some arithmetic operations or logic operations on a certain data type that is not string, you need to convert what the user has entered to that data type that you want to use. So for this one, you want to perform division here. But my 10, when it is entered, it will be a string. If you remember, I said the 10, when we enter it, it will be like 10 like this. But I want it to be 10 like this, not 10 with quotes. So if you do the int conversion, these quotes will be removed by the int function. So here, we're taking what the user has entered here, we convert it to integer, then to be assigned to variable number, then you are saying 10 divided by that number that you have given me. So if you give me 10, it should return 1 as my result. Actually, no result was printed here, so you will not see the result. This. So it should print the result here. If you give me 5, so 5 will convert it to integer. Then you need to set 10 divided by 5, so it will print 2. But what happens if you put A will try to be converted to an integer, but that will be incompatible. So I'll get value error, then value error will be ended by this body here. Okay, then also the same if I put 0, 0 will be converted to integer, which will remain 0, but only now this is 0 as an integer, not 0 as a string. Then 0 will be assigned to number, to variable number. Then you need to say, can you divide 10 by 0? This will say, no, I cannot do that. Why? Because I will encounter a 0 division error. But my try catch statement, I've commanded it to say, if you encounter a 0 division error, please ignore the rest of the code. Let's call what's happening here. So if I run this, then if I put just make this bigger. If I put 2 here, so I'll get 5. Why? Because it's saying 10 divided by 2. This work fine. If I run it again, if I put B here, B cannot be converted to an integer. This will result in a value error. So the value error here will say, please, you should enter a valid integer. As you can see, my program didn't crash. And also if I run it again, and if I put 0, I'll say cannot divide by 0. So this is error handling. I will use the try statement. Then there is also called a finally block. Okay, so from this, close this. From this try statement that I've run here, so this program will execute any moment that it encounters an error inside this program execution. It will see if that error been handled by your exceptions that you have put at the bottom. If it is not, it will encounter a runtime error. If it is handled, it will execute. So it will stop executing the body. Then it will go and execute the body of the error here, which is this is the error body, right? Then there is also what is called the finally block. The finally block is always executed no matter what. So even if I get an error inside my body, the finally block always gets executed. So the finally block executes the code regardless of whether an exception is raised or not. Okay. So for an example, if I have this code here, right? Okay. So if I try to open this file, I'm sure that this one doesn't exist in the same directory as my Python file. Okay, so if I try to open this file, I encounter a file not found exception. So you need to ignore the rest of the code. When it encounter this error, it will go to the file not found error body here and execute this. But after it completes executing this, it will execute the finally block. So the final block, its body always gets executed no matter what. So even if I encounter an error here, or if I don't, this will always execute. Okay, so if I run this, so like I said, I'm sure I'll get this file not found. Why? Because this file doesn't exist in my directory. So I'll get a file not found, but also I'll get this finally block get executed. As you can see, we have the exception being entered here, and we have the final block executed here. Okay, so this is how the final block works. Then as a programmer, you should be also able to debug your code. By debug, we say, how do you see errors in your program? How do you identify errors? So the ones that I said are difficult to find, these logic errors, we said you cannot see them because why? Because they will not stop your program to execute, and they will give you results, but you need to know if are your results true or not. So it's up to you for certainty are the results true or not. But maybe my program was tied up. It has many functions. We talked about functions, right? It has many functions. It has a large board of logic. So I need to know where exactly did my result get manipulated to be wrong. Okay. So I can say, okay, I have A which is equal to 5. I have B is equal to 10. Then I'll say result is equal to A times B. I'm just trying to write a bigger logic here. A times B. Then I'll say sum is equal to result plus 22. Let me just 20. The sum is an inbuilt word, so I can say total. Then I can say print total divided by 2. Okay, so as you'll be running this is not a bigger board. I just wanted to put a logic that is variables that are interconnected. So as you can see, result is depending on the value of A and B, right? And here we have a variable total, which is depending on the value of result, which we have computed by using the values that we had above here. Then we have total, which is making use of the result that we have previously calculated, and it's adding 20 here. Then we want to print total divided by 2. So if I get my value here, which is not the result that I'm expecting, I need to know where exactly did my program get wrong. Okay, so that, okay, this one. So we use the print statement, or in some other programming languages, we use loggers, what are called loggers. So each and every step, I can log the results or the logic or the output at each and every stage of the program, so that I will be able to track that my initial values were this, because I'll be seeing it in my on my logs. So if I run this, I'll only get the result here. If I run this, I'm not sure what the result is going to be. Okay, so it's 35.5, 35.0. But what if the result was supposed to be 40? How do I know where did my program went wrong? So that's when we use print statements. So initially I can print what was A here so that I can see it. Because when you take note, when you deploy or when you program a system, the users of the system will not be able to see this. They will only see this. How you come up with this value is not up to their concern. What concerns them is the result. So if you write a program claiming that my program is supposed to calculate your interest, maybe you are developing a program for a company saying we want a program that will calculate the interest, we give you rate, we give you principal, we give you this and give you that, right? Then you write the program, then you deploy the program. By deploying, I mean you package your program, then you host it on a server somewhere, then you give the users the access to your server or to your website if it is a website, or to your application if it is a mobile application. Then you give them your application. So what they'll do, they'll put the figures that you told them to put. Principal, they put rate, they'll put interest is what? Principal times rate times time over 100, right? I'm not sure the formula. But they have their statistics records, or they have their charts, or they have their trends. Like our interests were this last year, they were this year. Then your program will all of a sudden give them a result that is way, way off their charts. So they will start doubting your program, right? But you have produced them results. Only that results are false. So for you to be able to track those results, you need to know where did your program went wrong. So that's why what I'm saying here, you need to use print statements. Most programmers use this every day. It's not uh, advisable for production, but for development, it's very advisable because it lets you know where did your program went wrong. So yeah, I can print here what I had at A, what I had at B, what was my result here. Okay, what was my result here? What was my total here? So this helps me to debug both. For this A, I don't need to calculate anything because it's just variable definition and assignment. I don't need to calculate anything here. Here, when I get my result printed, I only need to compute these two values to see if this matches with the results. Then for this, I only need to take into account the result that I have had here and add it to 20. So this is quite easier to track the results, the the produced results, and what you expect. Rather than if I say, can you trace do a trace back of this computation? So you need to go back to how total was calculated, you need to go back how result was calculated, and you need to go back how A and B were taken from the user. Okay, so if I run this now, I'll get print statement at each and every stage. So I can this time I can see this was A and B, this was A times B, this was A times B plus what? Plus 20, and this was A times B plus 20 divided by 2. So I can now see where did my program went wrong. So if I was expecting a certain value which is different than the result, I can tell maybe at this stage I didn't divide it by the correct number, or I didn't add the correct number here. Maybe this was supposed to be 80, but I've added 20, so I can see that I have missed something. So this time I'll get an 80 that I want. So this is the first technique of debugging. Then also there are some IDE features like breakpoints to step through your code. So an example of a breakpoint, let me just, okay. So as you can see here, my program is executing from top to bottom, right? We said the program always executes from top to bottom. So it's starting from line number errors, or if I'm assuming that the actual results for step for this technique, usually you'll be having a logical error. So I may need to trace back where my program is getting wrong results or wrong computation. So I can use what is called a step in and a step out, which is the technique of using a debugger. So for this IDE, our tone uh, is not that big. It's just a simple IDE. It doesn't have many features, but I think it allows me to stop here. So this time, if I run my code, it will let me know when I get to line number 4. So if I run this, actually, this is not as expected. Line number 4, it did not notify me. But if we're using more advanced IDEs like this one, as you can see, this is IntelliJ, this is VS Code, this is Android Studio. These are more advanced IDEs. They have those tools when you can say, I want my program to stop here, and I also want it to notify me when it gets here. But this one, it's allowing me to put the stopper, but it's not notifying me when it gets here. I'm not sure what this tone is. Okay. Uh, okay, but that's not the point. But you just need to know advanced IDEs, they allow you to make use of uh, breakpoints through your code. So this one is allowing me to put a breakpoint, but it's not notifying me anyway. It was supposed to notify me on my console here. When it gets to maybe line number 2, I've put a breakpoint, but it's not. Okay, let me use a debugger script. Okay, so as you can see here, this time it is highlighted. So this one executed very well. Then when it gets to line number 2, it just gives me a highlight that you say you want me to notify you when you get to this line. So if I remove this, maybe I put this here, let me debug. Okay. So yeah, there are these features. Actually, tone is not that light like I thought. There are these features that you need to take into account, like I mentioned about this. The step into, the step over, the step out. The resume says, please continue executing the code. So the step into, we use it to continue the program. Maybe I have 2 breakpoints here. So let me just stop my program and start again. So I have 2 programs here. Well, I'm not supposed to say, and I was supposed to say debug here. So as you can see, this time it has got to line number 2 because I've put a breakpoint here. Then I can say, after this, can you step into this line and execute it going forward? So this will stop the program the moment the cursor gets here. It will stop the program. And it's me now who is in control of how we are going to execute. So this is, it has executed the print. Now it is printing the value of A, okay, which is giving me the result of what A is going to be. So A is going to be 5. Why? Because that's what A is here. So I can say, what's next? So this will print the whole statement. What's next? This will print 5, as you can see at the bottom here. Execute this line, creating a variable would be to put the value of 10. Execute the print, put 10 here. Then what's next? So these are tools that we use to debug. Then, so like this time I'm in control of what the program execution is going, not like how the run statement is. The run statement compiles the work code for me. So as you can see, this is a debug mode. This is a run mode. So this one will execute your program. It ignores all this breakpoints. Unfortunately, for it
Can't hear you
avoids
clearly.
all the breakpoints.
Mr.
But
Laz,
in some other IDEs, if I put some breakpoints here, if I click the run, it was supposed to stop at line number 2, which is the debug mode. About that debugging or dry running, we talked about mind. Like I will be saying, what's A here? A. Okay. So we did B here. What result? Hello.
your audio isn't clear.
Okay. I'm not sure why, but my network is stable and everything's fine on my side. I'm not sure if it is my network or your network, but I'm almost done though. So the last one here, this is dry running. Dry running is that, can you hear me clear now?
Yeah, we can hear you.
Okay. Dry running now, this is whereby me as the programmer or you as the programmer, computations on your own. The actions on your own, not letting the computer do that for you. Result is equal to 5 times 10. So result is 50, but my result is 50. So we're saying total is equal to print total divided by 2, but my total is 80. So total is going to be 48 divided by 2, which is 40. So that's dry running, running the code with my mind. So that is another technique that you can use. So that's it on error handlings. Then these are the assignments. You are supposed to correct errors and you're supposed to write codes with those error handlings. So yeah, for this lesson, I think I'm done.